Wayfarer 1 and Voyager 2 were outstanding space apparatus, a long way from being ordinary models. They were fastidiously designed with sturdy designs and a turn speed impressively slower than the hour hand of a clock, on numerous occasions over. This design highlight reduced apparent obscuring, permitting the rocket to catch both pictures and information at the same time as they navigated the boundlessness of space. Even before their missions took them to the external planets, their striking imaging technology had already begun to intrigue both scientists and the public. The shuttle began sending pictures of Jupiter months in front of completing their essential goals. These early pictures, showing twirling mists and the famous Great Red Spot, enthralled crowds at NASA's Jet Propulsion Lab. Anyway, it was the discovery of dynamic volcanoes on Jupiter's moon Io that truly took the spotlight. Slightly bigger than Earth's moon, Io ended up being the most volcanically dynamic body in the whole planetary system. The Space Charts instruments detected constant activity from Io, which was confirmed by the dynamic pictures showing towering volcanic emissions and a surface marked by volcanic deposits. One of Io's most outstanding volcanoes, Pele, erupted with a force commonly stronger than Mount Everest, covering a region almost the size of France. In the end, as the rocket's cameras shut down to preserve energy and memory before their excursion into interstellar space, it is important to note that the photographs they caught did not include Mercury or Mars for several reasons. Despite this, NASA proceeded to develop other exceptional shuttles, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 1 surpassed Pioneer 10, marking the moment when Pioneer 10 was surpassed as the farthest shuttle. Pioneer 1 continued its single journey for another 14 years, eventually entering the interstellar medium on August 25, 2012. Although there were no new remarkable space missions on the horizon, NASA did not publicly report this significant accomplishment until 2013. The S8 strain arose due to gravitational lensing studies, which suggested a lower than anticipated value for S8. In light of information from the Cosmic Microwave Background, CMB, research aimed at resolving the S8 anomaly has led scientists to examine a variety of hypotheses, from potential data errors to fundamental changes in our understanding of gravity. Contemporary simulations, like the Flamingo Project, have been instrumental in offering insights into the complex interplay between dark matter and gravitational forces in shaping the cosmic web. Despite the challenges presented by the S8 strain, many measurements at low redshifts and from the CMB remain consistent with the standard cosmological model. This has led to exciting theories that the universe may have undergone significant changes, pushing us to rethink our current hypotheses about the large-scale structure and evolution of the universe. In short, the S8 strain represents a significant challenge to how we might interpret cosmological designs and may require updates to our current theoretical structures. Traveler 1 continues its extraordinary journey, reliably sending back valuable information from the farthest reaches of the universe. For almost 50 years, this remarkable space apparatus has profoundly changed our perception of space. But recently, Voyager 1 has begun transmitting strange data back to Earth, leaving the entire space agency stunned. Are these disturbing signals the result of a malfunction, or could they be messages from extraterrestrial sources? Join us as we investigate the truth behind these surprising transmissions. For years, scientists have been intrigued by the questions that lie beyond our planetary limits. This curiosity led to the exceptional launch of Voyager 1 and Voyager 2, among other renowned space missions. These momentous missions, celebrated for their achievements, began with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. A couple of months later, on September 5, 1977, Voyager 1 was launched. These twin shuttles, each weighing around 710 kilograms, roughly equivalent to a small car, were sent into space during a specific alignment of the outer planets, marking the start of their remarkable journeys. The Voyagers traveled this way and that at varying speeds, culminating in a defining moment on December 15, 1977, when Voyager 1 surpassed its twin. From that point forward, Voyager 1 has evolved into a fundamental tool, providing vast amounts of data and unraveling the secrets of space. Before diving into Voyager 1's latest stunning discovery, which has greatly astonished the entire space agency, we should first examine the rocket's incredible contributions, especially its Jovian imaging mission. In 1978, Voyager 1 was situated around 265 million kilometers from Earth. From this vantage point, it began transmitting a wide range of images back to Earth. In January 1979, the van embarked on a 100-hour mission, capturing time-lapse photographs of Jupiter's rotation. This treasure trove of 3,750 pictures allowed researchers to observe Jupiter's dynamic movements in remarkable detail. Shortly after, Voyager 1 cleared its path through the Jovian moon system and made a significant discovery: a small ring around Jupiter and new moons, Thebe and Métis. This expanded our knowledge of Jupiter's fascinating atmosphere. To ensure a safe trajectory and avoid a potential collision with Titan, one of Saturn's moons, the rocket executed influence, speeding through space at an exceptional rate of 325 million miles per year. In January 1990, a new phase began, the Voyager interstellar mission. During this period, Voyager 1 captured some of the most iconic images in history, immortalizing the nearby solar system and most of its planets. One critical addition, expanding the mission's objectives beyond their original scope, was noted astronomer Carl Sagan. As a member of the Voyager imaging team, Sagan strongly advocated for one final set of images as a memento to humankind. Against all odds, his passionate effort succeeded, and on February 14, 1990, Voyager 1, situated 6 billion kilometers from Earth, captured the famous pale blue dot image. These stunning pictures, adding up to 60, were added to the shuttle's incredible collection of 670 photographs taken during its encounter with Neptune. Voyager 2, during its journey, made a notable achievement in recording wind speeds of over 1,000 meters per second, the highest ever observed in the planetary system. As it ventured 298 kilometers into Neptune's methane atmosphere, it provided groundbreaking insights into this distant planet. Neptune's largest moon, Triton, was identified as one of the coldest places in the planetary system, with surface temperatures plunging to extreme lows. Triton also displayed remarkable features, such as nitrogen gas springs and ice volcanoes that ejected debris up to 5 miles into its thin atmosphere. These surprising discoveries expanded our understanding of the diverse and complex celestial bodies that populate the farthest corners of our solar system. Recently, Voyager 1 has made perhaps one of its most disturbing discoveries. Before diving into this new, unsettling development, we must consider the rocket's vast achievements. The early observations of Jupiter and Saturn's moons left researchers in awe and challenged previous assumptions about these distant worlds. Moons once thought to be barren and inactive, like our own moon, were found to be rich in geological activity. Voyager 2, in particular, made several groundbreaking accomplishments during its journey. In 1986, it became the first spacecraft to pass by Uranus, and just 3 years later, it performed a flyby of Neptune, becoming the first spacecraft to achieve such feats. As the Voyager spacecraft continued their missions, NASA implemented various strategies to extend their operational lifetimes. Over the years, certain components and heaters have been deactivated to save power, ensuring that these resilient travelers can continue their function well into the next decade. The anticipated mission end date is set for 2030. For the scientists and engineers who have been involved from the beginning, the Voyager missions represent both a source of immense pride and a wave of nostalgia. Their tireless efforts have far exceeded expectations, and the wealth of data provided by the spacecraft has led to countless scientific discoveries, inspiring both researchers and space enthusiasts alike. Voyager 1 and Voyager 2 were not just ordinary spacecraft. They were the result of careful planning, powerful designs, and turn speeds generally slower than the hour hand of a clock. This innovative setup minimized apparent obscuring, allowing the spacecraft to capture data and images simultaneously as they traveled through space. Even before their interactions with the outer planets, their excellent imaging capabilities began to captivate scientists and the public. The spacecraft began sending pictures of Jupiter long before completing their primary missions. These early images, showcasing swirling clouds and the famous Great Red Spot, captivated audiences at NASA's Jet Propulsion Lab. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly captured the spotlight. Slightly larger than Earth's moon, Io turned out to be the most volcanically active object in our solar system. The spacecraft's instruments detected steady signals from Io, which were confirmed by the dynamic pictures they sent, revealing volcanic plumes and a surface scarred by volcanic emissions. One of Io's most significant volcanoes, Pele, erupted with a force typically greater than Mount Everest, covering an area nearly the size of France. Ultimately, the spacecraft's cameras were turned off to conserve energy and memory before their journey into the interstellar medium. It's important to note that the pictures they captured did not include Mercury or Mars for several reasons. Nonetheless, alongside Voyager 1 and Voyager 2, NASA has also launched other notable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Voyager 1 surpassed Pioneer 10, becoming the farthest spacecraft. Voyager 1 continued its solo journey for another 14 years before entering the interstellar medium on August 25, 2012. Although no major space missions followed, NASA did not publicly report this significant achievement until 2013. The discovery of the S8 strain, arising from gravitational lensing studies, suggests a lower-than-expected value for S8. Based on data from the Cosmic Microwave Background, CMB, the study of this anomaly has led scientists to consider various hypotheses, ranging from data errors to significant changes in our understanding of gravity. Current simulations, like the Flamingo project, play a crucial role in offering insights into the interactions between dark matter and gravity in shaping the universe's structure. Despite the challenges presented by the S8 anomaly, most low redshift measurements and CMB data still align with the standard cosmological model. This has sparked exciting theories that the universe may have undergone significant changes, challenging our current understanding of the large-scale structure and evolution of the universe. In short, the S8 strain represents a major challenge to how we interpret cosmological structures and may require updates to our current theoretical frameworks. Voyager 1 continues its extraordinary journey, reliably sending back valuable information from the farthest reaches of the universe. For nearly 50 years, this remarkable spacecraft has profoundly changed our understanding of space. But recently, Voyager 1 has begun transmitting strange data back to Earth, leaving the entire space agency stunned. Are these disturbing signals the result of a malfunction, or could they be messages from extraterrestrial sources? Join us as we investigate the truth behind these surprising transmissions that have reshaped our understanding of the cosmos and our place within it. The Voyager missions stand as a testament to human ingenuity, perseverance, and curiosity. These space probes, originally designed for planetary exploration, have become pioneers in the vast unknown, sending back invaluable data that continues to shape the future of space exploration. Voyager 1, now in interstellar space, continues its remarkable journey, providing data on the environment beyond our solar system. It has crossed a boundary that no spacecraft has ever crossed before, leaving behind the influence of the Sun and entering the true vastness of interstellar space. As it travels farther from Earth, the spacecraft's instruments continue to measure cosmic rays, magnetic fields, and plasma, offering insights into the conditions of the space between the stars.